Although the work is often said to almost everything we do all around the day, but in physics, the word work is always used in a very specific manner. In physics, work is only said to be done when there is a force applied. That means to say that any work is done, first should be that a force is applied on a body, that is, there should be a body, and an external force is applied, not internal. An external force is applied, and this force should make the body move. That is, there is a body, and I apply the force, and here the body has moved, which means there is a displacement in the position of the body. Then only work is said to be done in physics. That means there are two criterias, that is three, to be honest. Number one, there should be a body. Number two, there should be a force applied. And number three, there should be a displacement. That is, if we had to measure this work in physics, we would be measuring it by F and S. That is, force, any force that is applied, and any displacement that has been observed in the body, and their multiplication. Why? Because until and unless they both are met, the work cannot be said to be done. So work is only said to be done when first there is a force applied and second there is a displacement, that is magnitude of the force and the displacement of the body. If you can say, the SI unit is Newton for force and the SI unit is meter for displacement. So the unit for work would be, since it is a multiplication, would be Newton meter. So work unit is Newton meter, and remember this multiplication is because they both are doing the work together, and secondly this is for the scalar quantities. The sign we use is for the scalars and the dot we use is for the vectors. Now always remember that force and displacement, these both are the vector quantities. So the real way or the better way to write is F dot S. This is not in course, it is in 11th, but this is the correct way to write the magnitude of the work done, because they both are vectors and there is always multiplication is the dot product of the vectors, and it will give you a scalar quantity. But to simplify it, force into displacement is equals to work. And also, now suppose there is this body and a constant force is applied to this body, okay, but this body applies an equal force. That means it is it cancelled out, the force is cancelled out, therefore the body will not move, and since the body will not move, there would be no work done. Now although we are applying some force to it, but still the body is not moving, that means there is no displacement in the body. And how do we calculate or measure work? We calculate it by F into S. That means if, let's say, I'm providing it 10 Newton force but displacement is 0 meters, therefore my work would also be 10 into 0, that means 0. I'll be doing no work in the physical sense, that is, in the affairs of physics, we would not say that this is any work done. But if you are tired, it would mean that you have done the work in your daily languages. This is the basic difference between how physics and daily languages work. Now, it is also not necessary that if I apply force to a body, it would only move in the direction of the force. If I apply force to this body and here is the plane surface, obviously the body will move in this direction, and here, let's say, we'll have our body. This is the initial position and this is the final position. These are not for the velocities. This is just in initial position and this is the final position. It is not always necessary that if I apply force, my body will only move in the direction of force. There are some cases where, like, let's say in an inclined plane or a surface, if force is applied here, then my body may move from here to here. That is if I apply enough force. So here in this case, my body is not moving in the direction of the force. Let's see here, this is the direction of the force, right? I'm applying force here, so my body should move here, but it cannot because the surface is inclined, right? This is the surface and this is inclined, so my body should be moving here, but this is not the direction of force, right? This is the direction of displacement. My direction of displacement and force, they're not the same. Now how do we calculate work done in this kind of situation? That is, if here's my body and here's this inclined surface, if I apply force here, let's say of 50 Newton, and my body is now here, due to my applying force of 50 Newton, my body has moved a distance of, let's say, 5 meters. So my body was first at here, but now it is at here. So how are we going to calculate any work which is done? First of all, we know that force has been applied, and we also know the distance has been covered. But my body is not in the direction of any force. This is the direction of the force here. So how are we going to calculate any work? Consider this. Here my force has been applied to the body, and this should be the distance it should have covered. That is, from, let's say, name here A and B. This is the direction of my force. That means this should have been the distance if my body was on a regular surface. But here is an inclined surface, so my body has moved from here to here. So this is my displacement, and by definition, work equals to force into displacement. So it should have been that 10 Newton into AB, whichever distance this is. But here's the catch. Distance is this now. The displacement is this now, not here. It has been changed. Why? Because there is an inclined surface like that. ये होना चाहिए था ना, because the body would automatically move in the direction of the force. Why? Because had it been a regular surface, my body would have moved in the direction of the force. लेकिन अब यहाँ पे उल्टा है. यहाँ पे हमने ऐसे सरफेस की जगह ऐसे रख दिया, तो अगर आप बॉडी को यहाँ पे मूव कराओगे तो बॉडी वुड नॉट मूव इन द डायरेक्शन ऑफ फोर्स, रादर इट वुड हैव इट्स ओन डायरेक्शन, दैट इज इन द डायरेक्शन of the surface where the surface is there. In such a case, we'll take this angle and this displacement. That means my work done would be F into S cos theta. This is my expression which is in the course. So this would be expression when you're dealing with work done to in body or work done by a person or by a force when the body moved, or the displacement, that is S, is not in the direction of the force. Had it been a regular surface, the body would have moved in the very direction of the force, so we would have only applied this formula. लेकिन यहाँ पे एक angle create हो रहा है from the actual distance which should have been, but between the actual distance which should have been and the other distance which is the reality. Okay, that is the surface, the real one which has been moved from A to C. It should have been A to B, but it is A to C. So in this case we would use Fs cos theta, which means we'll use AC cos theta. AC is named as S right now, so we'll use force, that is 10, and then we'll use S cos theta, whichever the distance traveled is.